Okay, happy Thursday. We're going to move on to templates. Uh, there's not a lot in this chapter of Zybooks, but it sets the stage for what we're going to do with linked lists and stacks and queues. So we're not going to do a ton with it today, which is why it's okay. We got a little bit behind. And we'll have more time to work on the recursion project. We got break next week. Don't come, you'll be lonely. No one else will be here. The week after that, we'll get into linked lists, which is a bit of a tough topic. It's a unique way of looking at data and storing data and working with data. So we're going to spend the whole week on that one. Um, we'll go over the project two solution, and then our last project here will be based on not necessarily linked lists, but the idea of linking objects together and keeping pointers to objects. That gets to be a lot of fun. Now, the week after that, we'll do the midterm review and the midterm. So the 13th, I'll give you last semester, last time I taught this class, I think it was last year's midterm, because I have to rewrite them anyway. Not that you folks would, but some people post those on CourseHero.com, which is a violation of the academic integrity policy anyway. But at that point, people have gone too far if they're on CourseHero. Um, and then we'll go over the answers on the 18th. Should be fine. If we have anything extra from linked list, we might have a little bit more of linked lists to do on the 18th. And then the 30th, midterm will open at 3:30 and it will be due 3:30 on the 25th. It's untimed, open book, open notes, open internet, not open neighbor. Right? This is your individual effort. It's not meant to be hard. This is, hey, we've gone through most of the rest of the topics here. So you've kind of gotten the rest of CS2. Then we're going to shift gears and move into some data structure stuff. Um, check in on that. And then move on to stacks and queues, more data structures. Talk about project three. We'll start our group project. Ideally, this is pairs. Group is a bit of a misnomer. There's just not enough work to do. Uh, we're not going to give you a big, 200-hour project that you need a group to work on. This is something you can do with the pair. But we do need to work in partners with this. We can't do this one individually. So if we need to, maybe we can do one group of three if we got an odd number here. And then searching and sorting out of Zybooks, streams out of Zybooks, and then ethics is just a separate thing with notes. This is part of our accreditation process to be an accredited computer science degree, engineering degree. We have to talk about ethics, which is good. We should be talking about ethics. So you'll hear it in several classes from here on out. Not necessarily just its own class, but kind of incorporating that into what we're doing sets the groundwork for that. And then the last week here of April of class time is set aside just for you to work with your partner on the group project. I can answer questions. We'll have all that time set aside. We will need to do the lab on the 15th so we can get through ethics, but that's like a 20-minute lab. So it's not going to take a lot of time. So you can have most of lab time to work on that final project. Again, ideally, if you're done by the 17th, life is good, right? Then you can actually worry about your other finals where people expect you to memorize crap because that's tough. And I get it. So if you're done by the 17th, fantastic. All we have to do is worry about showing up and running your program, answering a couple questions about your code here and there. It's going to feel high pressure because it's worth a lot of points and you're presenting it, but this is something we're going to do all the time in industry. You're going to write some code and show your team, right? All your peers, hey, this is what I worked on here. I need some feedback, that sort of thing. But this will be silly because we're all doing the exact same project. There's not really as much opportunity for feedback, but gets us started there. So that's the plan for the rest of March and April as we look forward to the first fall spring, winter coming again, having another fall spring, getting a snow in April, all that fun weather stuff. But thankfully, the sun's out a little bit later at night, and we'll be moving back to daylight savings time, which we should just keep forever. All right, so let's talk about templates. Let me make a new project here. This is week 8 templates. And the Zybooks just has 2 sections here. So the first one looks at template functions here. And the next one looks at class templates. So most of the time, what we're going to be doing is class templates here. Occasionally, you might want a function template. They're fun and interesting, but that's sort of sets the stage for this. So the idea with templates is we can use different types. And we've been doing this the whole time. We're just not really knowing that's what a template is. And our namespace standard, and we're going to include vector. So when we make a vector here, we say, hey, I want a vector of, and then in these greater than less than brackets, braces, signs, I forget what we call them here. We say, hey, this is of type int here. This is my numbers. So vector is a template class. We're saying, hey, this instance of vector uses integers. So we're telling this template here what type we're going to be using. So when we write template functions, we do that same idea where it's generic and it doesn't need to know specifically what type it is here. It'll still operate on whatever we want to do here. So I can say, hey, I'm going to do the avoid function here, and we'll just call, I don't know, print 3 times. It's kind of boring here. Given what? Well, I need to be given something here. And now we could be like, hey, I want, an object doesn't even work very well here. If I want to be able to give it anything to print here, I'm going to use a template and say, hey, I will tell you what type you are here. So we add this little template uh, declaration here to the top of our function. And I hate calling it the type. Most of the time we use T. So type name, and then T now represents whatever type they're giving us here, because it's going to be consistent. So when you use this function, this T will always be the same type. Like in this vector of integers, the T is int. It will always be integers when we're working with integers here. So here's the T, I don't know, value, and then I can see out the value, and then line, and maybe let's put a little loop in here. So for int, I don't know, number 0, numbers less than 3, number plus plus. And we can go and print this thing 3 times of whatever the type is here. So E then represents whatever type I'm giving it here. It's the parameter for my print 3 times value here. And it can work for any given type. So I can call my print 3 times function, print 3 times. I can give it, hey, the number 10, or I can call print 3 times, 3 times. I can give it the string test, right? So in this case, this constant character array is the type. In this case, the type here is an integer, right? I can even give it other things too, right? If I wanted to write a class, or some class, and it doesn't even really need to do anything interesting here, I can give it one of those, some class, and I can call print 3 times, given some class, right? Whatever we pass it is going to be represented by this T in here. So it's generic at this point here. So I can run it. Oh, goodness. Nope, I broke it here. Oh, yeah, I didn't specify that one. Shoot. Is it just the sum class one that broke it? Might just be the sum class. Yep. So it breaks on sum class because it says it doesn't know how to print it here. Right? We get a build error. No output stream operator found, which takes a right-hand type of T. So it won't compile at this point because it doesn't know how to output this thing here. So with some class, we can define that output parameter here. I even forget how to do that. I'm just going to go, we'll ask the chatbot here because that's fun, right? So here's my sum class. We should probably add like an attribute here, right? So private string for, let's have an int for number here. That's all we need, just to have something in here. And we'll go ask chatbot here. How can you see out this class? Maybe it'll figure that out here. That's not the best prompt. Not really proud of that one, but let's see what we get. Here we go. Look at that. We have to overload the operator for it here. Generally, what you'll do is you'll say this is a friend function, which gives you access to the private attributes here. C++ is a big fan of friends with benefits. If you're a friend, you have access to their private attributes. I didn't come up with it here. It just always amuses me, and that's how I remember it. I apologize. So we're going to declare this function here as a friend type here. And these get kind of messy. It's okay. We're just going to copy paste in here, and we can cite our source, right? This was UMGPT. GPT. Here was our prompt. Here, something like that. It says, okay, how do we go and do this? So the values that you give this get to be a little bit funny looking here. So this output stream reference is what we're going to be returning. And what it accepts is an output stream reference and an instance of this class here. And I like my inline declarations. That's kind of messy here. I'm sorry, but it's just easier that way here. And then to actually do that, then we go and take our output stream, and then we insert this into the output stream here. And this is the object's number, right? That's the number attribute. We have private access to it because we were declared as a friend here. And then we return the output stream. The reason why we need to return the output stream is so you can chain it together here. So when we go output this thing, we're also then outputting the end line. Kind of this one goes into this one, goes into this one. And with our order of operations, we've got cout and then value first. If it returns the output stream, we can just keep on going and not have to do it on a separate line here. That just makes that life a little bit easier for us here. So now this one should compile. No, did it not? I didn't give it the reference. Is that what I have to do? The reference here. It's some class. Oh, we never initialized it here. Okay, so let's go and make a public some class and set number equal, I don't know, 0. Is that gonna be happier now? Hey, there we go. And now we get the sum class number was 0 and it outputs. A lot of work to make this so we can output here, but this template type, if we're going to output it, needs to be outputable. It needs to know how to work with the cout thing here. So you can use this for lots of things. They don't always have to make a lot of sense here. So there's another example they give you. I think it's like find the sum of 3 things. So if we say, hey, I want a template, type name. And again, it doesn't have to be T. It doesn't have to be the type. It can be ABCD. It's essentially like a variable here. We're just going to use it. So most people use T. And this will be a void, or no, it'll be a T, we'll call this the largest here, of T first, and T second, and T third. So if you give me 3 T's, a first, second, and third, I'll give you back a T, which is the largest one of those T's, right? So if my first is greater than the second, right? And first is greater than the third. This is going to be a little bit messy here. That's okay. So first is greater than the second. If first is greater than the third, we're going to return first. If it's not, then else we can return the third. No, we can't even do that, can we? Then we have to check. Man, comparing 3 things is messy. Do you have to have 6 comparisons? I feel like you need to have a lot of comparisons here. Because, oh no, it's only true if first is greater than second, but I don't know if third is greater than that or not. All right, so we have to check, I guess. So an if, this is dumb here, sorry, and first is greater than third. All right, we'll just do it this way here. We can return first. Just combining it this way and having 3. Yeah. Well, the IntelliSense here is really obnoxious here. It wants you to give sample templates here. That's kind of annoying. And then if my second is greater than the first, and then the second is greater than the third, return the second. And if it's not the first and it's not the second, it's got to be the third, right? I can just return third here. So we can just do it with 2 checks, I think. Let's try it and see. So we'll cout largest of about 2, 7, and 5. Line. Make sure that one works. So we should get back to 7 if we did it right. We got back to 7, and if we put it in the other order, we still get a 7. We still get a 7. Cool. Now, if we want to cout the largest of some class, and some class here, do you think this one's going to work? Can I compare, is this one greater than this one or greater than this one? No, it doesn't even build for me. It says, hey, it doesn't have the operator. So by using templates here, we get this cool compile time checking. It's not even going to run and crash on me. It just won't even build. Won't even try and run because it recognizes, hey, you can't do this thing with that given T. Doesn't work. So we can go add it in here if we want, right? We can go override that operator here. So I can say Boolean operator greater than given a constant, some class reference. Is it just other? I don't know. What do we call this one here? Other. And then I'm going to return number greater than other dot number. If I'm greater, great, we're greater. Let's see if we can do that one now. Nope, no build errors. Shoot. Can't access private member. I have to call this one a friend one too? Really? Is that what I have to do? No, that's not right. Greater. I can make a public function here. That seems annoying. That's my error. I can't get private member operator. Oh my goodness. I wrote that in the private section here. It should be in the public section. That was my error. Not the number itself, but that one. Okay. And then we can see which one's greater. You know, it's all the same one here. It's not very interesting. So maybe we want to be able to set that for number. And number equals 0, the default. And then this number can equal the number. This number. Right, so I shouldn't be able to make one that's bigger. So some class, that one's a 0. And then a bigger class. And a smaller class. So I don't know, like -5 should be smaller and bigger can be like 10. And then we got some class, bigger class, and smaller class. So now we should give out the 10. Hey, we got the 10 out. Yeah, it's a little bit silly. These examples are not super useful most of the time here, but it gets us introduced to the idea of templates here, where I've got some type that will be constant in the rest of the function here. Excuse me. Now, vector is actually a template class, not a template function, right? So when we declare the class, it's a given type here. So that's what we're going to see next. So we can write our own template classes here. So I can have a class for, I don't know, what we want to call this one. They do like triple. Triple's kind of annoying, but that's okay. Call this one a pair. Actually, we already did a pair, right? We used the pair in our last lab here. We shouldn't do pair. How about we have, I don't know, associations. Why not? And then we'll make this a template of type name T here. So a class for associations, then we have to add in, there's another line we have to add here. What does that line look like? We have to add in, oh, that was it. Okay. We don't have to add it more. So now anywhere in this class, I can have T be a given type. So I might have a private section and the public section, right? We'll have, hey, here's a T for, here's the word and the T for the definition or something. I don't know. This isn't really great being templates here, but that's okay. We're just practicing. And then we can make a associations function here. And we want to take a T for word and a T for definition in our constructor. Set this word equals the word and a this definition is the definition. We can set these things here. So we'll give it 2. How about we call it key and value? I like that. That's what, like when we do our maps here, we do keys and values. So let's do that. We'll do key, apply, and we'll rename this one to value here. Okay, so now we got keys and values. I didn't rename those ones. Shoot. Key and value. Key and value. All right. So now I can make an instance of this one here. It's not super helpful, right? We probably want a way to get these things back out. So like a get key, turns the key, and a t get value, turns the value. So I can go set and get these things here now, right? And the return type is whatever this template is, whatever you want to call this one here. So I'm going to go and make one of those here. Can do it up at the top maybe. Here's my associations. What type is it? Just like we did vector of a given type here, we'll say, hey, this is of type string. I guess we should use string. Include string. Okay, so I'll have an association of type string here. This is my dictionary. Um, I need parentheses. Okay, cool. And then, oh, we never gave it. We have to give it some values here, right? So we might have uh, C++, and then the associated value with C++ is annoying programming language, right? And then I can do things, right? I can get my cout dictionary dot get key, right? And then line and the dictionary get value, get value. Right? We're just holding like, here's two pieces of information here, but they're both of type string here, right? So, so yeah, when you're using it, you say, I will use it, and here is the type I'm going to be using it as. In the class definition, it doesn't know what type it's going to be. It's just some kind of type here. So keys and values are fun, but having them to be the same type is kind of obnoxious here. So if you want more than one, you can have more than one. We just comma separate. So type name. Now we can't use T again because we already used T. So a lot of times people do K and V for key and value, or T1 and T2, or whatever you want here, right? It doesn't really matter here. And I'll have T1 and T2, T1 and T2 here, so I can store two different types here, right? And you can have a bunch of these. I think there's a limit somewhere around 16 maybe. I forget what it happens to be, but you probably aren't going to need that many here. So one, two, maybe three, depending on how fancy you want to get here. But now we can have two different types. So when I go create it now, it doesn't like it. It says, oh, what's the other type here? Well, it's string, comma. It could also be string, but it couldn't maybe be integer, right? And we'll say, hey, this one relates to, I don't know, what do we have, 14 now? I forget what, 21 version of C++ is current. 23, there we go. Okay, we're on 23. It's been a little while, I guess, since I looked it up here. But again, it still works here. Fine, we can do these things. So C++ in 23, we get our key, we get our value. It works the same regardless of what types we give it, as long as we can do those things. So for just a get and set, we don't even have sets, or we just have gets. It's not going to matter what the type is here, right? We're not trying to output anything. We're not trying to check greater than or less than. So you can give me any type you want here for these types. So they did, hey, you've got three things of it. You can get all of them. You can get the minimum item. Yeah, similar idea here. Which one is the smallest? Um, there we go. Sure. And then, hey, this one is a bunch of integers. This one is a bunch of shorts. Sure, you can do all of those ones here. Yeah. So that's our class template. Is there another section? How does that not show? Oh, it does. It is here. Okay, the map values. Okay. So we used, this is a building your own map, right? When we did our own section with the standard template library, the containers here, right? It has a map type already built in, right? You say, hey, I want a map. Here's the type of string. Here's the type of int. We've done these already. Right now we're learning how to build them ourselves, which again is not super interesting for most of the cases here. But once we start talking about linked lists and building our own containers that store things, yeah, I want to be able to store anything. Right? I don't want to limit the user to only be able to store integers or strings or floats and have to worry about doing all that other stuff myself here. So if you want to write your own class templates here is super helpful if you want to be flexible on what you're storing here. And again, it works if those things have those correct operators, right? So you have to be able to compare less thans or greater thans or whatever we're doing here. So if we just wanted to flip around our largest here to be smallest, right, we'd have to go and implement the other less than operator, right? Because right now it's only checking for the greater than. So it's really cool. You get the compile time checking is, hey, you gave it this type, but does it really fit here, which is cool. So I think the same idea, like we could sort dictionaries and things. There's a function for that in the algorithms library. It's not going to let you sort things unless you can actually compare them greater than or less than. Right? I think did we look at that one when we looked at our vectors? Did we look at sorting or did we not yet? Somewhere in here, sort. Uh, yeah, the comparison operator from chapter 6. We did sort. I love this search feature. It's nice. So if you include algorithm, right, you can sort from a given endpoint here. right? As long as those things are sortable, right? So this vector of review only works if you've added in this one here. Oh, look at that. They did a constant at the left and the right-hand side. Okay, sure. I didn't bother with that. I just had the one, right? So they actually were able to define this outside of the class, but either way seems to work okay. All right, so we've got template types for functions, template types for classes. It's about all we need to do with them right now. Right? When we come back on Tuesday, we'll actually build our own linked list, which is a template type, sort of like a vector. You can add and remove things from it. It's nice and friendly, but it'll be a template class, and we'll have had all of spring break to forget about it here, which is, sure. We can do a little refresher if we need to on the 11th, but I think that's about all we need to cover today. I don't need to hold you too long. Making sense? Or at least enough? Okay, cool. So we'll come back to that. Don't forget the checkers project we're working on, our recursion project. We got that one's due coming up on the 13th. So if you got questions, let me know. If you want to forget about it for all the break, that's okay. Actually, take some time off. It's good for you. Come back. We can talk about it more on the 11th. Talk about it in lab. That sort of thing is fine. Just don't wait till the morning of 3:13 for questions, please. Okay, that doesn't go well for people. Great. Awesome. You folks take care, and I will see you in 2 weeks.